So we're going to go through some of that tomorrow, and then next week we'll be studying our final topic for the HSC course, financial maths. Yep. Okay, let's have a look at question 11. People are given a maximum of 6 hours to complete a puzzle. The time spent on the puzzle in hours can be modeled using the continuous random variable x, which has probability. Grace, do you need a booklet? Okay. Continuous random. So what was I reading? Which has probability density function that. Okay. So the graph of the probability density function is shown below. The graph has a local maximum. All right. Okay. Let's have a look at the first question. Part A. Ladies, show that A is equal to 2 over ln 10. All right. Girls, the first thing that we need to do, if you look at the function in the piecewise function, they've given you that. What we want to do is integrate it from what values did they give you in the question? Yeah. Okay. And what does that has to equal to? If it's a, yeah, it has to equal to 1. So from there is how you calculate A. Okay. Now, the first thing you want to do, A is just a constant. Oh, sorry, I forgot to write X next to it, sorry. So you usually want to take the A out because A is just like a number. All right? So take it out. It's just you integrating this. Do you remember how to integrate that? It will be ln. It's going to be ln. Differentiation of the bottom is 2x with the 1 on top, which cancels out. So the answer is just half ln x squared plus 4. If we 6 and 0 multiply with the, okay, we write the a on top. You can do that. If you've got a half out in front, multiply the a out there as well, and that should equal to 1. You girls with me? You can have the a out in front. It's the same thing.
But can you sub the half out as well?
You could. Okay, it's the same thing. So, all right, let's substitute it in. For this one, I have a over 2 ln 6 squared plus 4. That's 36 plus 4. That's 40. Take away a over 2 ln. If I substitute 0 in here, it's just 4. That's equal to 1. All right? You with me? Factorize a over 2 out. Now, girls, can we stop, please? Thank you. Thank you. Now, girls, if it's a minus in between, how can we put these two together? Yeah. Remember from log rule, I can put it like this? Yes. Do you remember that?
Yes.
A over 2 ln 10 equals to 1. Multiply the 2 across. So a ln 10 equals to 2. So a is equal to 2 ln 10. So that's not too bad, is it? Yeah? So there's our first mark, question part A. Now, I need more space here. B. Show that the mode of x is 2 hours. So remember, mode is the most common score, which we can find graphically is the stationary point. Yep. So what we want to do is differentiate basically this, the original function. All right? But don't put that a value back in. Just differentiate it with the a. It just makes it too complicated if you sub it in and then try to differentiate it. So how do I differentiate this? You don't remember? It's a quotient rule. Bu dash, or however you like to memorize it. Yeah? So what's u dash from here? A? Just a, yeah? Yeah? Yep, so let's not make any silly mistake here. Alright, vu dash, that's this times that. 4, take away uv dash is that times that. So 2, no, I'll just write it like this for now. Or like this, is that alright? But you remember a is a constant? Okay, yeah, thanks.
Education access scheme, right?
Okay, so we got this. Yeah, you with me? Sharon, come on. Okay, so from here we need to make it equal to 0 because we're trying to find the stationary point. Yeah? So what does this become? Let's simplify this.
To get the a
ax squared plus 4. It won't expand it because what are we trying to find here, girls? What are we trying to find here? The stationary point, because the mode is the stationary point. So what do I need to do here? Look at that. They're like terms. So we have this. Yep. Yep. So take away a. I'm going to write it. Oh, hold on. X. Yep. And then from here, I mean, you get plus or minus 2, but you can only take positive 2 because there's no negative 2. That's basically the answer. And do you know how back in our exercise we have to test the stationary point? Apparently in the answers they don't do that and they just left it like that. So you know how we found the stationary point, but we don't know if this is a min or a max. Now, apparently, I don't know if we're supposed to, but in the answer they didn't. They just said that's it. That's the answer.
How do you know it's the mode if you don't test it?
Well, in order to test it, you got to differentiate this again, which is.
Can't you solve it?
Oh yeah. You could do that. Yeah. Oh, that's right. Okay. What I'm saying is, in the answers they didn't test it, so I'm not too sure.
Test it now.
But for your sake, to be safe, test it. So that would be.
You have to sub in the ranges as well, just to maximum points. Like the.
Well, before you do that, test if this is the max first. If we get the maximum point here, yeah. But honestly, girls, look, I can't be bothered. But if you look at the graph, that's clearly a 2 there. Yeah, you can see the mode 2 is at the peak. So let's just stop there. But if you need be, yeah,
You should test, right?
you should. Okay. All right. Show that. Come on, girls. Show that the probability of choosing less than 2 is log 10 2. How do we do that? We just want to find the probability from the graph.
You have to integrate.
Yeah, you just have to integrate it from 0 to 2.
Why is it 0 to 2? Why would it not be x? Usually, isn't it?
No, we want the actual value. We're not trying to get an expression.
Oh, okay.
Okay? Yeah, that's right. We just have to integrate. You know what this is? Oh, yeah, girls, this is what I wanted to point out. What's my A?
2 over 10.
That's going to cancel out with the 2 at the bottom, isn't it? So is this all right?
1 over ln 10.
Good. Now, if you substitute this bit, you're going to get ln 2 as well. Now, which means this. But how do I get from this to that? You can just honestly write it, but do you remember why though?
Oh.
Anything on the top? Bottom. Because remember, if you wanted to evaluate that back in year 11, yeah, we have to. Yeah, that's by the answer. We good? Okay, before I move on, actually, girls, I need more space than that. Can you take a photo of this? Because I want that side of the board. Because of people are normally distributed, which I drew up on the board. Okay? It says it's got a mean of 100. So it's there. Standard deviation of 15. So I've written it up there. Now, girls, it has been observed that the puzzle is generally completed more quickly by people with high IQ. It is known that 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. Let me just stop right there. Let me read that part again. It is known that 80% of people with IQ greater than 130, so what that means is anyone above IQ with greater than 130, it doesn't mean all of them can complete the puzzle in less than 2 hours. It means 80% of anyone above IQ 130 can complete the puzzle in less than 2 hours. Does that make sense? That's the one part that actually I was confused. Now, a person chosen at random can complete the puzzle in less than 2 hours. What is the probability that this person has an IQ greater than 130? All right. So, what we need to... Okay, here's the question, right? The probability on top. Okay. Does this make sense? Girls, probability in general, what is it? It's the total outcome, going back to year 8 maths, So this is obviously your general probability formula, right? You want the outcome out of the total outcome. This is it. The total outcome is all the people that can complete the puzzle in less than 2 hours, yeah? But the one that I specifically want are these two conditions. IQ with greater than 130, and within those people can complete it in less than 2 hours. Does that make sense? So, we know 80% of people greater than IQ 130 can complete it in less than 2 hours. So, here's what I need to know though. What percentage of people is that though? What percentage of people is that, going back to our percentages?
2.5.
Yeah.
2.5. 80%.
That's right. So in this normal distribution, 2.35 plus 0.15, which is 2.5%. There are 2.5% of people with IQ greater than 130, but within that, only 80% of those people can complete it in less than 2 hours. Does that make sense? So 2.5% obviously is 0.025. Now, but what's the bottom though? People who can complete it in less than 2 hours. Girls? Now, hold on. Go back to our previous answer. Girls, we answered from part C. Show that the number of people that can complete it in less than 2 hours is, we have the number there. Yeah, so this is how you get it, and the answer comes out to be, that's your answer. Very tricky question.